Okay, in this lesson we're going to look at deriving the first three trigonometric formulas. There's a number of formulas on our course we have to be able to use. There are 9 of them we have to be able to derive. I'm going to talk about deriving the first few of them. I'm going to start with just making sure we understand a few basic details, and then we're going to derive what we call the Pythagorean identity. Sine squared theta plus cosine squared theta is always equal to 1. So suppose x comma y is a point up here. X comma y, that's my point. Such that its argument is theta, so I'm calling this angle here with the top side of the positive x-axis, that's theta. And its absolute value here, or its modulus, is or. That distance in there is or. Okay. A couple of things to note. I could complete a little right triangle in here, and I can show that x squared plus y squared is equal to r squared. That's just the Pythagorean theorem. Also, from our definitions of sine and cosine, sine would be y over r, cosine would be x over r. So I'm going to derive, using that information, my first of my trigonometric formula. This is known as the Pythagorean identity. And you're going to find that when we do a bit of work with this, we're going to find that it's equal to 1. It's a constant value. It doesn't change. No matter what angle I put in here, sine squared of an angle plus cosine squared of the same angle is always equal to 1. A couple of things to note. The squared here, when we're writing sine, if we square the sine of an angle, we write it as sine squared of the angle. The squared goes between the trig function and the argument. I don't know why that is, but that's just a kind of a notation. So sine squared theta means square the sine of theta. Okay. So sine squared theta, well, given that sine of theta is always y over r, sine squared of theta is going to be the square of y over r. Given that cosine of theta is defined as x over r, well, the square of cosine theta will be the square of x over r. Squaring everything out, here we'd get y squared over r squared. Second fraction would be x squared over r squared. Combining those, we're going to get x squared plus y squared over r squared. Note also that x squared plus y squared is equal to r squared. So that's actually equal to r squared over r squared, which is 1. Okay, so that's an important identity. No matter what value you use for theta, if you square the sine of theta and add it to the square of cosine theta, you will always get 1. And you should know that. Commit that to memory. It's in your log tables, or your formula and tables booklet, I should say. It's on page 13, I think, up in the top right hand corner. Find it, but know it, and you've got to be able to derive it. Okay? You might be asked in exam to derive the Pythagorean identity, and that's how you do it. You've got to do the whole thing. You've got to start up here and write the whole thing out, and that's how we derive it. Okay, write the value of c if b is equal to 10 and a is equal to 120. Well, from our new definitions of cosine and sine, cosine is equal to the x-coordinate divided by r, and sine is equal to the y-coordinate divided by r. So the x-coordinate can always be written as r cosine, and the y-coordinate can always be written as r sine, whatever the argument is. So if I want to write this, I can write it as, well, if it's telling me that b is 10 and a is 120, well, then the point c can be written as modulus 10 times cosine of the argument 120, comma, modulus 10 times the sine of the argument 120. And that's called polar form. When we leave it like that, that's called polar form. We can change that into rectangular form by just working out what 10 cosine of 120 is. You can plug it into your calculator. It's going to be -5. Well, let me go through why that is. Cosine of 120 is here in the second quadrant. The reference angle would be 60. Cosine is negative in the second quadrant. So cosine of 120 is going to be the negative of cosine of 60. Cosine of 60 is a half. Cosine of 120 then is going to be negative a half. 10 times negative a half is negative 5. Sine of 120 is going to be the positive of sine of 60, because sine is positive in quadrant 2. Sine of 120 is equal to sine 60, which is root 3 over 2. So 10 times root 3 over 2 would be 5 root 3. This is called rectangular form. This is called polar form. They are both saying the same thing. They're both different ways. They're two different ways of writing the value of the same point. Write the value of c in polar form. Well, here we're given that the modulus is b and the argument is a, so we would write this as b cosine a, comma b is sine a. Why? Because my new definitions for cosine and sine. Cosine is always x over or, sine is always y over or, where x comma y is a point on the terminal side of the angle. Okay, so the x coordinate can always be written as or cosine the argument, and the y coordinate can always be written as or sine the argument. Okay, I want to derive the formula for the area of a triangle. A couple of things to note before we get into deriving it. When we're naming triangles, and we're talking now about formulas for triangles that are not necessarily just right triangles, which we dealt with at junior cert, but for any triangle. When we name the sides, you know, if I'm calling them A, B, and C, well then I name the angles also A, B, and C in the following way, that the angle A and the side A are opposite each other, the angle B and the side B are opposites, and the angle C and the side C are opposites. The sides always get lowercase letters, the angles always get capitals. Okay. Any triangle can be placed with one of its vertices in the standard position. Here I've put C in the standard position with the vertex at the origin and one side along the positive x-axis. The coordinates for this point A, well, they'd be whatever the length of B is, comma 0. The coordinates of C are of course 0, comma 0. It's at the origin. Why? Because I've put it there. I've chosen to put it there. And then this angle up here, or this vertex I should say, can be written as, remember, it can always be written as the modulus times the cosine of the angle. In this case the argument will be capital C, because C is the angle at the standard position, comma the modulus A times the sine of the angle. So that's kind of my initial setup. I want to derive the formula for the area of a triangle, and I do it by using my formula from primary school, which said the area of any triangle is equal to a half by its base times its perpendicular height. So in this triangle, a half times its base, well in this case I've placed B on the x-axis, so I'm going to use that as the base, B is the base. And then the perpendicular height, well the perpendicular height is going to be however high it is above the x-axis there. And that height, hopefully you can see, is going to be whatever the y coordinate is. It's going to be A sine C. So it's going to be half times B times A sine of C. So therefore, the area of the triangle can be written as a half times B times A sine C. I'm just going to write that as AB, little a, little b, sine capital C. What does that mean? Well, that means the half times the length of one side times the length of another side times the sine of the angle between them. A half times the length of one side times the length of another side times the sine of the angle between them. It's important that we have the angle between them. The other thing to note is I could have used any side. I didn't have to put B here as my initial side. I could have used any side. So I could have also said a half AC sine B, or a half BC sine A. Okay, and you have to be able to do that. You have to be able to derive the formula for the area of a triangle. How do I do it? Well, I place my triangle with one of the vertices at the origin. I label my vertices A, B and C, label my sides A, B and C. Deduce that that has to have coordinates b comma 0. Deduce that that has to have coordinates a cosine c comma a sine c. It's in polar form. And then just use your old primary school area of a triangle formula. Half base times the perpendicular height. Okay, the last thing we're going to do in this lesson is to derive what we call the law of sines. Okay, and actually I don't really need the picture anymore to do this, so I'm actually going to ditch that. We're going to just be using this kind of idea, what we derived over here. We're going to be using these kind of three equations. So what we said was that the area of any triangle can be written as a half times AB times sine of capital C, or a half times AC times sine of capital B, or let's move this out of the way. A half BC times sine of the angle A. All we're saying is it's a half times the length of one side times the length of another side times the sine of the angle in between those two sides. So we have an equation, there's four sides to this equation. I'm going to focus on these three, this side and this side and this side, and I'm going to just double all those sides using the multiplication property of equations, which says if every side in an equation is multiplied by the same quantity, then all sides remain equal. So doubling all sides gives me that AB sine C is equal to AC sine B is equal to BC sine A. The doubling, of course, just cancels out that half. The next thing we're going to do is use the division property of equations, which says if you divide on all sides of an equation by the same quantity, then all sides remain equal. I'm dividing on all three sides here by the quantity ABC. And what happens is this cancellation. The A's and the B's cancel there. Here the A's cancel and the C's cancel. Here the B's cancel and the C's cancel. And we're left with this very important statement, which says that sine of big C over little c is equal to sine of big B over little b, and that's equal to sine of big A over little a. And this is called the sine rule, or the law of sines, and you need to know it. It's in your formula and tables booklet. I think it's on page 16, and it's derived from the area of a triangle formula. So if you're asked to derive the sine rule in your exam, first you would have to derive the area of the triangle formula, then you derive the sine rule from that. Okay, and obviously if fractions are equal, well then their reciprocals are equal, so we can write it in this way as well. A over sine A is equal to B over sine B equals C over sine C, or we can write it as sine A over A is equal to sine B over B is equal to sine C over C. Generally we use the first kind of form if we're looking for a missing side, and the second kind of form if we're looking for a missing angle. Okay, in our next lesson we look at applying that. Okay, but you got to be able to derive those things.